Here we go with objective 58 with our difference of cubes rule and our sum of cubes rule. So what we're going to look at here is we've already done this greatest common factor rule. Remember to always check for that first. Okay, and the second thing on our list is the difference of squares rule. Now the difference of cubes rule and the sum of cubes rule works a lot like the difference of squares. It's just that if you check out their initial starting formats, we had a squared minus b squared for the difference of squares rule. Well, for the difference of cubes rule, I'm going to have a cubed minus b cubed. The other important thing to note is that there is no sum of squares rule. However, we do have a sum of cubes rule. Alright, and it is a cubed plus b cubed, so very similar to our other two formulas. Now there's a small difference in the solution. If you check out the difference between the difference of cubes rule and the sum of cubes rule, you'll notice that the difference of cubes rule starts with a minus sign, and then the rest are remaining that are pluses. And then the sum of cubes rule starts with a plus sign, and then it goes to a minus, and then is a plus sign again. You'll need to memorize these rules when we eventually take the assessment over these objectives. Let's see how the difference of cubes rule works. Difference of cube rule states if you have the difference of two cubes, it equals the difference of their cube roots times the square root plus the product of their cube roots plus the square of its cube root. Basically a minus b times a squared plus ab plus b squared. What you'll see is a problem like this: x cubed minus 8. So first of all, we have this x cubed thing. Important to note, any exponent divisible by 3 is a perfect cube. And the reason is, when it's divisible by 3, you're able to say that that quantity cubed equals whatever. So, for instance, suppose I have x to the 12th. X to the 12th is a perfect cube because x to the 4th to the 3rd power is x to the 12th. Let's change that up a bit. Suppose I had x to the 15th. X to the 15th, well, that's equivalent to x to the 5th to the 3rd power, which is x to the 15th. So any exponent that is divisible by 3 is a cube root. Now, is 8 a cube root? Remember earlier this year we talked about this x cube list and values of perfect cubes. Well, you should start to be very familiar with some of the more basic perfect cubes. 8's a perfect cube because 2 to the 3rd power equals 8. Okay, so now that we've recognized all that, here's how we're going to apply our formula. Our formula says a cubed minus b cubed. Well, right now, this a cubed is the x cubed, and this b cubed is the 8. What I want to do is break the a cubed and b cubes down into their components that are going to fit into the formula, so the a and the b. Well, if a cubed is x cubed, that means that a is x. And if b cubed is 8, that means that b is 2. Now I just substitute the a and the b into my formula, so x cubed minus 8 is going to equal x minus 2. I'm going to square the a value, so when I square the a, that gives me x squared. I'm going to multiply the a and the b, so that's going to give me 2x. And I'm going to square the b value, so 2 squared gives me 4. So x cubed minus 8 equals this quantity. I need to go back and double check to make sure none of my factoring rules apply again. Important to note that this trinomial, although we have yet to talk about trinomials, will always be prime, which means that it's not factorable. So primarily we need to check to make sure that this first binomial, this x minus 2, is not something we can factor. There's no greatest common factor. It doesn't fit the difference of squares or the difference of cubes rule. That's why the x minus 2, x squared plus 2x plus 4 is my final answer.